Continuation from the previous video. So this is actually the gradient, which is 2. It's actually the gradient. It's the acceleration. Okay, dv over dt, this is the acceleration. Now, if I take v and I differentiate again, okay, v equal to 2t minus 4. If I differentiate again, dv dt, which is actually the acceleration, d2s over dt square, this acceleration is 2. Okay, so d2 dv d2 is 2 if you differentiate with respect to t. So d is the acceleration. It's a constant acceleration. Okay, as time go on, it's a constant acceleration. Now, there's something here that need to highlight. You can see that at this point here, below this point, the v is negative. Above this point, the v is positive. What does it mean? That means we know that at the beginning, when t equals to 0, is travel this direction, which is negative. I mean, from t equal to 0, this onward is traveling at the negative value of v. Okay, why? Because it's traveling in the opposite, the negative value. Okay, that's why here, this part here, you can see is negative v. But the moment it turn, at the turning point, it travel this direction, the velocity is positive already. So this part here, the velocity is positive already. Okay, so therefore, what is this point here, t? It basically is the value where you have the turning point. So this is basically 2. Okay, the turning point when the velocity from negative to become positive. Okay, and then this one is actually the acceleration. Okay, but this one, if you differentiate dv dt, you got a constant. Okay, so it's a constant acceleration. But sometimes the s function could be t3. Okay, it could be t3 with a t2. Then by the time you differentiate d2s dt square, you got a function of t, not a constant, but a t function. Then that means to say, if you plot v versus t, okay, that means to say, let's look at another case. V equal to 2t square minus 4, let's say. So if you plot this, it become a quadratic function. So if I differentiate this again, then it become 4t. Okay, so this is an acceleration, but this is not a constant acceleration. This acceleration depend on the time. Okay, this one, if you plot this one, the acceleration will be a horizontal line. This one, if you plot, this is t, then your acceleration will be constant, dv dt, acceleration all we go, or v2s. Since it's a constant, so it's a horizontal line. So it's a constant acceleration. Now, if let's say I have v equal to b, when I differentiate dv dt, I got 4t. That means to say, let's say this is dv dt, acceleration, then it's a straight line. For example, draw mistake. Okay, now okay, for this case, Okay, this is dvdt acceleration. So you plot this is 4t. Let's say this dvdt versus t 4t. That means to say that the acceleration will depend on the time. At a different time, at a different time, at a different time, their acceleration is different. Okay. In this case, when you dvdt you get a constant, your acceleration is a horizontal line, it's a constant. So it doesn't depend on the time. So now another thing is if you want to find the distance traveled from 0 second until t equal to 4 is basically this distance, okay, plus this distance, okay, basically it's twice, okay. So but bear in mind this, uh, let's look at where's the distance traveled from here to here. Okay, now as t equal to 0 is 0, as t equal to 2, I mean at this point here is equal to uh, 2 square minus 4 times t times 2, 4 times 2 give you minus minus 4. Okay, when at this point here distance travel is minus 4. That means we have gained the distance of, if you just talk about distance travel, is equal to 4. Taking the scalar value equals 4. Okay. Uh, if I put s equal to t, s equal to t equal to 4, what do you notice? The 4 square minus 4 times 4, which will give you a value of 0. After the t second, the if you use the uh, the the vector value, the distance is actually back here. So t is equal to s equal to 0. That's correct in terms of displacement. But this will not tell you the distance traveled, the scalar value. But obviously we know from here to here is 4. You need 4 distance. When you go back to t equals 0, another 4. So if you want to make a statement, total distance traveled from t after, wait, this not proper. I should change it to after 4 seconds is equal to 4, from here to here 4, and then back to the original another 4. So it's 8. The distance traveled is 8. Okay. So you cannot get the value by just substitute the t. Okay, why? Because this is negative s, and then this is the gain in the distance, so they cancel each other. Okay, they cancel this distance and distance will cancel, so you got a 0 if you just substitute the t. Okay, so what you have to do is, in this case you have to find the distance from here to here, and then sometime you have to work out this distance to this point before the turning point. Let's say at this turning point, find this distance before the turning point, and then after that from the turning point to wherever the other time, so you add both together. Then it will not cancel